Welcome to lesson number 7. This video should be watched after you complete the Desmos activity that went in class after you did your quiz. In the Desmos activity, we defined the reciprocal function. The reciprocal function is f of x equals 1 over x. It was discovered that when we divide by 0, we get asymptotes, and this function will never equal 0, therefore we get a second asymptote. Your domain for this graph is x as an element from negative infinity to 0, in union with 0 to infinity, because we have a vertical asymptote when x equals 0. Remember, x by itself is a vertical line, giving us that vertical asymptote at the origin, making the graph discontinuous. Our range is from negative infinity to 0, in union with 0 to infinity. Again, we can never make this function equal to 0 because we have a horizontal asymptote when y equals 0. I think it's important that we label each of these as the asymptotes, and I like to highlight them so that my brain visually can see where those points of discontinuity are. The other function we learned about in our Desmos activity was the reciprocal squared function, and this takes on the form of 1 over x squared. For your domain, the domain is the same. X is an element from negative infinity to 0, in union with 0 to infinity, giving us that vertical asymptote again at x equals 0. The range on this graph, because it's squared, all of your values are going to be above the x-axis. So y is an element from 0 to positive infinity. We use the parenthesis because we want the whole graph above the x-axis. Again, our horizontal asymptote is at y equals 0. Again, I like to highlight those and label them so that I can recognize them and my brain visually sees that discontinuity. Notice that this one is even. It's the same reflection over that y-axis, and it kind of mirrors each other. I like to think about this one like a volcano. In each of our transformations, we can locate this standard form, y equals a over x minus h plus k, or y equals a over x minus h quantity squared plus k. That's the standard form for both reciprocal and the reciprocal squared function. What we learned from looking at the YouTube activity was that the horizontal shift changed the location of your vertical asymptote. On both functions. The k, as we know, is our vertical shift. Therefore, that controls our horizontal asymptote. So as I move this graph up and down, we can see how those transformations are going to affect the range, the domain, and those end behaviors. Let's start by going through an example of a reciprocal function. When we look at our denominator, that's going to help us with our horizontal shift. We know based on functions that this is moving to the right by 2 units. That ends up being the location of your vertical asymptote. I like to graph the asymptotes with highlighters. That way I recognize exactly where they are and can label them as separate from my graph. Remember that a vertical asymptote is x equals. The horizontal asymptote comes from the vertical shift this graph is getting moved up 3 units. So that's going to change the location of my asymptote from y equals 0 to y equals 3. Again, I'm going to highlight that and label that function. From here, just like in our parent function, we always have a point that's 1 unit over and 1 unit up from where those two horizontal and vertical asymptotes meet. And we have a point that is 1 over and 1 back from the location of the horizontal asymptote. The function then is going to get that little bit of a curved shape approaching both ends of the vertical and horizontal asymptote as I go to positive and negative infinity. So the goal of lesson 7 or 6 is to talk about how the end behavior statements can be written. So we're going to have a total of 4 end behavior or asymptotic statements. When you think about your function, there are 4 arrows. Therefore, each of our statements have to be about those 4 arrows. So I'm going to start with statement 1. As x approaches positive infinity, that means we're going all the way to the right, y is approaching 3, and I'm going to put a little plus up here showing that it's approaching from the top. My second statement is about the second arrow on the left, and I'm going to say as x approaches negative infinity, y approaches 3, and I'm going to put a little sign underneath of it showing that I'm approaching from under. My third statement is going to be about the behavior near the vertical asymptote. So as x approaches 2 from the positive side, that's from the right, y is approaching positive infinity. And as x approaches 2 from the negative side, from the left, y is approaching negative infinity. So notice that I correlated those 4 statements to the 4 arrows you see on the graph. Statement 1, as x approaches positive infinity. Statement 2, as x approaches negative infinity. Statement 3, as x approaches the vertical asymptote from the right. And statement 4, as x approaches the vertical asymptote from the left. Let's do this one more time with a different function and see what we can figure out. Again, we're going to start by looking at that denominator. The function tells me how the graph is going to be shifted. This graph is going to be horizontally shifted to the left by 4. That's going to give me the location of my vertical asymptote. Again, I'm going to use the highlighter and label that. The vertical shift gives me the location of the horizontal asymptote. This is moving up 2. Therefore, my horizontal asymptote is going to be at y equals 2. Now that I have my graph labeled, normally the function would be in quadrant 1 and 3, but because it's also has been reflected across the x-axis, it's going to be in quadrant 2 and 4. So instead of that point being 1 over 1 up, it's going to be back 1 and up 1, and then give me that curve, and then forward 1 and down 1, giving me that curve. Again, we want to make sure that we put arrows on both ends. Use those asymptotes as your boundaries. We're not going to get across those boundaries. From here, I can write my 4 directional statements. Again, I like to label those with the numbers 1, 2, 3, 4, just so you can kind of put 2 and 2 together with what the function is and what the end behavior is. So here's 1, here's 2. Those are the 2 ends that are approaching the horizontal asymptote. Here's 3 and 4. Those are the 2 ends that are approaching the vertical asymptote. So let's write out our statements. As x approaches positive infinity. Y is approaching 2. Notice that this time it's underneath of it, so it's approaching 2 from the negative side or underneath. As x approaches infinity, negative infinity, y is approaching 2. This time that chunk is above it, so it's approaching from the top. Our next statements are going to be about the behavior near the vertical asymptote. So as x approaches that vertical asymptote of -4 from the positive side, so we're talking about from the right, y is approaching negative infinity. And then our fourth statement, as x approaches -4 from the negative side, y is approaching positive infinity. Let's look at example 3. This one is a definition of a reciprocal squared function, so it's going to look like the volcano. The transformations, though, behave the same as they did in another function. Because of this denominator, that's our horizontal shift, so it's moving our vertical asymptote 2 units to the right. So I'm going to highlight that. And again, I'm going to label that. The next transformation is my vertical translation, and this is -4. So that vertical translation is going to move your horizontal asymptote down 4 units. And I have my horizontal asymptote. This one is the volcano. So in quadrant 1, it's going to look the same. So it's going to go from that location of where the asymptotes meet. It's going to go 1 over and 1 up, and then have that same shape it had before. But because of the squared feature, it's going to be 1 back and 1 up. So you get this function that looks like this. Again, I think it kind of looks like a volcano. Notice we still have 4 arrows, so we still need to state our end behavior and our behavior near the vertical asymptote. Again, I'm going to label those so that it makes sense as we go through those 4 statements, which arrows I'm referring to on each. So for statement 1, as x approaches positive infinity, those y values are approaching -4 from the top. So we put a little sign up in the power for positive. Arrow 2, x this time is going to negative infinity. So as x approaches negative infinity, y is approaching -4 again from the top. So these two statements are the same. Statement 3 is as the behavior approaches the vertical asymptote. So our vertical asymptote was at 2. So as x approaches 2, y is approaching positive infinity. And arrow 4, as x approaches 2, from the negative side, y approaches positive infinity. So notice those two end statements are the same, both going towards positive infinity. Let's look at one more example of that reciprocal squared function. Again, let's start with looking at our denominator. That's a +3. So the graph is moving to the left 3 units. And that's the location of our vertical asymptote. I'm always going to highlight that and label appropriately. Then the graph is moving up 5 units. That's going to change the location of the horizontal asymptote. So I'm going to draw in the horizontal asymptote and label appropriately. Okay. The last thing I notice about this one is that it has a reflection over the x-axis. So now instead of my volcano opening up, my volcano is going to open down. So I have a point 1 over 1 down from the location of where those asymptotes meet. And then the other graph is symmetric over that line of y or x equals -3. gets upside down this time, so you still have your volcano, but this time it's upside down. Again, in regards to those arrows, notice we still have 4 arrows. 1, 2, 3, and 4. So we're going to have 4 statements about the location of those arrows. Let's start with arrow number 1. As x approaches positive infinity, y is approaching 5 from under. So we put from the negative side up in the power. As x approaches negative infinity, now I'm going to arrow number 2. Y is approaching 5 again under, so I put a negative sign. Arrow number 3 there. As x approaches negative 3 from the positive side, from the right, y is approaching negative infinity. It's getting bigger or smaller and smaller and smaller as it goes down. Our last statement, as x approaches negative 3 from the left, from the negative side, y is approaching negative infinity. These are our 4 directional statements for this particular function with these 3 transformations. What I would like you guys to do is we'll do some more examples in class, but if you guys could try that problem down in the lower right-hand corner, 1 over x minus 3 plus 5. Please draw out the graphs on a piece of paper, add the asymptotic behavior, horizontal and vertical, and then try and write the statements for your 4 directional statements.